Pay attention to this little animation there. That's the same animation that we had on Rustfest, if you were there. Like, very important detail. Took me ages to do that. Was worth it. Totally worth it. So, Rust. Question is, what is Rust? And to be more specific, what is Rust doing behind the curtains? So you might think you know what Rust looks like, but maybe you haven't looked below, behind the curtains. You haven't really seen what Rust will do with your code, how it will execute your code, what are the limitations, and so on, the constraints. And sometimes it's helpful to know your tools a little better. So that's why I wanted to give this talk. First off, who am I? Who has seen a YouTube channel called Hello Rust? Like, see a few people, right? Wait, let me do one thing, man. It was, of course, staged. That's like unique because there's only one of these shirts because I never got around to start the campaign. But, yeah, one of you lucky people can win it. No, not this specific one. Or you might have heard from my blog. Who has seen this logo before? More or less no one. It's embarrassing. So most of you have no clue who I am. And that's cool. There's a funny story. Yesterday I was sitting here, like in the middle somewhere. And I was sitting next to a guy and I asked him what he's going to watch tomorrow. And he was like, yeah, I will be at the Rust talk for the first two. Ah, there you are. He was like, don't point me out, man. And I said, oh, cool. Show me the thing about Rust behind the curtains. That's really interesting. And he had the picture of me open and he didn't recognize that was me. So I think that's a good thing because in reality it's not about me, it's about Rust. So I think that's cool. I work for a company called Trivago. It's a hotel search platform. We have a few million accommodations. We have IT departments in Düsseldorf, Leipzig, Parma, and Amsterdam. And we do a lot of languages, so mostly Java, Kotlin, Go, Python, maybe some Rust. I haven't said that we do Rust, but I also haven't declined that. So we have a tech blog, if you want to check that one out. That's our campus. And now you might be wondering, why does Matthias have this pile of things there on the table? And if you can see from behind, like I had the most creative idea to push that one. And so you can guess what it is as it's forming. Socks. Pay attention to the manly leg on the top right side. That's my favorite part of it. They gave me some socks. Wow. And I thought, like, what am I going to do with those? Well, I'm going to throw them at people. Yeah, you can see me now? Better. And I will do random questions throughout the talk. No pop quiz. But then you can win socks. And finally, before we start, there's one thing that I forgot last time. In fact, who was there last time? Last year? You deserve a pair of socks right there. This is how you sell those things. Otherwise, oh no, that was a horrible mistake. I already regret that idea. Wait. Also, I forgot to mention my girlfriend Anna, so I hope she's watching now because otherwise it's her fault. And yeah, there we go. So I covered that part. Now let's go back on topic. Why should you care about Rust internals? We all have read the documentation, maybe some more pages about Rust. Here's one. That was like one of the first ones we had. So Rust is a system programming language that runs blazingly fast, prevents seg faults, yada, yada, yada. Most people don't care. Because let me point out a few things here. These are all terms that you have to know to understand what this definition means. Oops, oh, I was off from the mic. And this is not really approachable. This will put people off. They will say, wow, why should I even care? I stopped reading after thread safety, but there's also advanced type system, garbage collector, static analysis, deterministic drops. What is a deterministic drop? Why is it important in a definition of a programming language? Well, it is important, but not to foster curiosity. It's important to know what you can do with this language, that's correct, but you want something easier, something more attainable, something where people can relate to foster their curiosity. So the new definition that we have, I think it's much better. It's empowering everyone to build reliable and efficient software. No deterministic drops in there, no seg faults in there. It's just what Rust can do. It's not what it is what it can do for you. And that's a whole different ballgame. Everyone is empowered to build reliable and efficient software. And that's a really bold statement, and that's a really cool goal, and this is why I like Rust. If you want to translate that into Matthias English, then I would say, be curious, try crazy things, don't be afraid. You cannot possibly fail. Failure just means that you learn something. If you fall, you always fall forward, so that's also a movement. Andy said that yesterday. So I like this image from also, again, RustConf, I guess. This is Lucy, and she built this steampunk rocket engine, and she's flying around with it. And that's really cool because she built it herself, and it gets her, it brings her to the next level, right? She can go higher now. That's what it's about. So we should aim for that. We as a community, we should aim to introduce that to the people so that they understand what Rust is about. Don't start with seg faults. Start with empowering. Start with curiosity. Another one. This is also from RustConf 2018. Lucy is climbing high up there, and this is kind of dangerous usually. But then again, she's safe because she's on this leash. And if she falls, she doesn't fall hard because this tiny little robot there that definitely can hold her weight, he's gonna keep her safe, right? But still, I like this metaphor because the human is in control. The human decides where to go, but the robot helps the human get there. And it's such a powerful metaphor. Or as Pascal said, and then I will stop with those things, he said, being curious is an amazing trait. He said trait there, I don't know if that was a pun, but we should embrace it and help people be curious. And this is exactly what I think it should be about. And how can you do that? How can you foster curiosity? There are people in this community and in other communities that do exactly this. For example, who of you has heard of Julia Evans? Socks, oh my God, you don't get socks, sorry. Like the kind of first, if you lift your hand more than once, then you won't get socks. Yeah, well, okay, you also get socks, but then again, that's it. Those socks, usually people don't care about the socks, but yeah, if you give them as a prize. So Julia Evans is doing those comics about various systems things, and she's making them approachable. She's showing people what you can do with the language without being patronizing, without being very, very low level. She can do all of this with simple images, descriptions, and really, I like it a lot. And I see a few nodding people. I think she's onto something there. Another example. Who has ever heard of this? Chunky bacon? Socks time? One final socks time and then... So who was it? Well, okay, just pick up your socks later. Why the Lucky Stiff? This is like the full name of this community member from the Ruby community, and he had wrote this book, Wise Pawn and Guide to Ruby, and there he describes Ruby in a very different way, in an artistic way, with comics. A lot of it doesn't make sense, but in the end, it all fits together. So I loved this book as a child. I read it a lot, and I was like, wow, this is programming. This is curiosity. This is like, wow, this is crazy. This is so out there. And I wanted to try the same on Rust. And when I started with Rust, it felt like this little dog. And I wanted to learn more about this Rust thing. I was curious, really. I wanted to figure out what this was about. But whenever I tried to kind of touch it or dabble with it, it would move, or it would be different, or it would not be approachable, and I would have a hard time to figure out how to get started. What would be the first step to learn more about Rust internals? And so the disappointing end was always that I lost track, I lost motivation, I lost my goal out of sight, and yeah, that was that. So another lost opportunity. And I think a lot of people feel this way. Maybe you also try to learn more about Rust internals in like, yeah, when I get around to it, or well, I don't really have what it takes, or yeah, I have other things to do, or it's too hard. And for this talk then is for you. What's the Rust compiler? Rust is written in Rust. It's a bootstrap compiler. There are a few steps throughout every Rust compilation process. First, you take the Rust source. Then you desugar that into here, the high-level intermediate representation. And then you take this representation and you more or less desugar it again. You do borrow checking there, you do optimizations there, and then you have mirror, which is the medium intermediate representation. Then you do more optimizations, and you end up with LLVM IR, which is the LLVM backend intermediate representation, which is more or less just bytecodes, so to say, some operations, similar to the Python interpreter bytecode. You might think of it like this. And then LLVM compiles it to machine code. In fact, Rust is just a front end for the LLVM compiler. But let me focus your attention to the top of that part. There's one more step which was recently introduced, which is the hair, which is more or less similar to here, but with some more optimizations being done. And the reason why this, and also why mirror was introduced, was that the compiler was very, very hard to maintain, and a lot of features were very hard to implement without those abstractions. For example, if you have ever heard of non-lexical lifetimes, this would have been almost impossible without mir. And it's good that we have those abstractions, and it's also good that you don't have to see them on a regular basis. But still, I think it's good to know what those abstractions are, so that you know what the compiler is doing, so that you can interact with it. And you have more control, you have more guidance with what you do. Desugaring is the part of the compiler which takes your input and produces output that the Rust compiler itself can understand. It's more or less simple Rust. You can also write simple Rust. You can do it yourself, but it would be very tedious and very hard to maintain, and you would lose a lot of functionality and convenience and syntactic sugar. So this is why the compiler does it for you. It takes your code and it transforms it into something healthy for the compiler. We all love vegetables. That's why I have those vegetable images, not because I did not have any other idea for this slide. The compiler does everything for you. You might say, Matthias, okay, we're in this talk for a while. Can you show me an example? Yeah, I'm glad you asked. Let's look at an example. So the first example, imagine a perfect world, the only bug-free program, an empty main. This is what you write. This is not what the compiler sees, though. Maybe some voices. Anyone knows what is missing there in the slide when the compiler runs that? Yes? Yes, yes, an arrow and open close parentheses, yes. Some more maybe. But the most important part is when you use Rust and you use a string, well, you have never imported a string. Did that ever cross your mind? You use a vector, but the vector, you never said use standard collections. Vector, right? So there's something going on there. And that is what they call the prelude. One thing is the standard library. Those are all the things that you need on a daily basis. And the prelude includes stuff from the standard library. So that's why you need both parts. The standard library is just another crate. It's just something that you can compile into your binary, but it can also run a no standard build, and that's also completely fine. Then you don't have allocators and all that functionality from standard library. And this prelude includes all of this. You see those tags above the imports, the prelude import. That's just for the compiler to know that this is kind of a special import. You cannot really do that yourself. This is like an unstable thing. That's why we also have a version 1, because there might be a version 2 of this prelude. And so it's a smart idea. And what will you get when you just include this prelude? You will get all of this. A few types, a few traits, and one function. The types are, let me clean it up a little bit for you. The types are things that you need in almost every Rust program. Option and result, string and vector, and some of you might have heard of a box, which is just something like a smart pointer. You have something on the stack that points to something on the heap, and more or less everything that is dynamic, like a string or a vector, is also a smart pointer. And that's quite a helpful abstraction. You have all those partial equal and partial ordering traits and so on, and I can group that up even more for you. The first part of set of traits is for ordering things. The second part is for converting things, from making it a reference, making it mutable, converting it from or to another type, into a string, cloning it, and so on. Third set is for just the default value of your thing. Sometimes very helpful. For example, the default of string is an empty string or something. Then something like an iteration. Then you have those marker traits, which get optimized away at compile time. Those are just hints for the compiler to tell you what to do with your code. So you declare this as being able to be copied, or this being able to be sent over to a different thread. Then you have a few traits for, as I call it, calling or dropping objects. A lot of things are callable, and even things that you might say like new is something that you call an FN on, so you need those traits in the scope. And the last thing is kind of the weirdest thing, but it's for concatenating objects, more or less. Like strings and vectors, when you want to add things to those vectors, you need that all the time. Okay, that's nice, but not really code that you would write yourself. Let's look at a concrete example for code that you would write, that then we can de-sugar and see what's going on. So just keep in mind that there will always be this part of the prelude in every Rust program. We don't care about this anymore. Now we just care about concrete code. And who knows what this will print? Nothing, yes. Yeah, I'm stupid. But so the iteration goes from 0 to 2. Yes, exactly. It's an exclusive range. What you could do is you take this part and you make that a little bit more explicit. So maybe you move that into a separate variable. And then you take that and you make it even more explicit. And then you call a struct creation on it. So range will get a start and an end point. And this is exactly doing the same thing. Well, let me move that over a little bit, because we need more space. First thing we need is import our operations range, because that's not in the scope. Remember, it's not in the prelude, so we have to import it ourselves. And then when we look at this loop, we are not really done yet. We can optimize that loop. And if you were writing a compiler, you would optimize it a little more by saying, okay, I don't really need this for I in range. I can also say, while let sum equals iter next. So that's a lot to take in. But you can see that we create an iterator from our range at line above. And then we call while let sum equals iter next, which means as long as there's a next element, do something with it in the loop. Just one way for the compiler to not handle the for stuff, it can map that to a while loop. But even that is very, very sugary for the compiler, so it will do more. And every while loop can also be translated into exactly a normal loop. So a loop over an infinite range, more or less, or an infinite loop. And then in every iteration, we check the iterator. And if there's an element, we do something with it. And if there's no element, yeah, we break. Well, that's awesome. How did I figure that out? Turns out that the compiler allows for inspecting this. And it's no secret, but it's also kind of hard to start with that. So that's why I wrote a little tool called cargo inspect, which will do exactly this for you. You give it some code, and it will print what the compiler will see. And if you want to follow along, you can just cargo install cargo inspect, and then call cargo inspect on any Rust file or any crate. And now, here's one more sock time, because I need someone to hold the microphone while I type. Oh, Luca, that's so nice of you. Well, like, yeah, this is not going to work. I appreciate that you try to have very long arms, but... Okay. That's awkward, because my screen is not really mirrored. Oh, that's horrible. Ah. Yeah. So let's say I have a crate here, and I'm typing this blindly, and I have something like very, very simple here, like a normal opening of a file. Ah, that's better. I can now say cargo inspect, and it would just unroll whatever the Rust code is doing behind the curtains. So you can see colors and syntax highlighting and pagination, everything works out of the box. Yep, thank you. I will need you more often. Inclusive ranges. Well, if you look at this example, it's similar to the other one with one minor difference. Who can spot the difference here? Yeah, it's easy. Okay, it's an equal sign. What this will compile to is that. And where's the difference here? Yes, it's the range inclusive. It's more or less the same thing, but yeah, it's an inclusive range. So you might say, why? If I iterate over my code, that's kind of very hard to spot, right? Because I have this one example, I want to compare the outcome with another example. So how can I compare those outcomes? How can I compare what the compiler is generating? And so that's why I added a feature called cargo inspect -- diff. And you can give it two input files, and it will generate the diff for you. So this is very experimental. Yeah, you need to hold the thing again. Oh, so professional. I would love to mirror that screen right now. Wait. I have an idea. So here you can see you have two examples. One is range and the other one is range inclusive. And now if you run the diff command on it, you will see the outcome. And there's some problem with the syntax highlighting right now, so that's why I need an additional flag. But I'll fix the syntax highlighting soonish. You can see that it's more or less, explaining to you what changed when you changed this one letter. So it's kind of easy to spot then what's going on in the compiler as you iterate. You can even set a watcher for it and then interactively do that output. But let's not focus on that right now. I think it's really helpful though. Yeah. You have already seen the compiled output of this example, but I want to go through this step by step and tell you what's going on. So this is a very simple example for opening a file. Okay. We say let f equals file open, file.txt, question mark, and we have an OK value. First off, why do we need an OK return value? Because this function will return a result. You can return results in main now. And there's two cases. Either this operation will succeed, in which case we return this unit type, or it will fail and we return an IO error. So far, so good. But could you explain what this question mark operator does internally? That's the carrier operator. Fun story, I talked to Nico Matsiakis, who implemented that. I said, how did you come up with the carrier operator? He said, what is the carrier operator? So apparently it's just me using that term, but okay, fine. That carrier operator, this question mark here, is really peculiar. Because if you were involved in Rust for a longer time, you would know that this was not really possible. Before this question mark operator, there was a try macro. And before this try macro even, there was syntax to make this error handling very explicit. So what do you have to do in this case? You know that the file operation can fail, and you have to check for this condition. File open will return a result. And the result can have two options, OK or error. So what you could do is you could match on that result and say, if it's an OK file, then just assign file to F. If it's an error, actually return an error. So don't even assign anything. So we're done, right? Well, what happens if our error type is not really the error type that we return from these functions? In this case, it should be an IO error. But as you know, you can use the carrier operator for many, many other errors, including your own errors. And how does the compiler know what to do in this case? And there's a very, very smart thing that is in the compiler, which is the from conversion. As long as there's an implementation of the from trait, or actually into, of the from trait, because into is implicit, as long as there's this conversion going on, you can call it, and the conversion will happen at compile time with all the safety features. So that's what the compiler is really doing. It's converting this error into a from from error. So it's calling from on your error. And if there's no from, then sometimes you will get this weird error message saying into something is not defined, blah, 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 for this type. And this is what's going on. It's trying to call from, but your trait implementation doesn't exist. And that's super helpful in many, many different cases. Very powerful metaphor. Okay, let me show you again this code that we had before, and I don't need Luca for that. I do need Luca for that again, I guess. Yep. Okay, so you can see it's running on a cargo crate. It was running on a cargo crate because that's an entire crate, just to show off that it can also use crates. And this is more or less the fully explicit, unrolled, desugared file opening code that you saw before. The only thing I did was removing some of the includes. Yes, 1 second, you will get the microphone back in a second. Yeah. Now, most of the time, you don't work on the IDE. You use your actually you use your IDE. You don't work on the terminal for interacting with your code. So why not use this functionality from your IDE? Hold it. I got you covered. Yeah. So let's create a file. Let's call it test.rs. And let's just write some Rust code. Okay. And now let's see what the compiler is doing. I just open my IDE and I say cargo inspect run. It's going to produce this output for me in a separate tab. And you can see how print is implemented. How cool is that? How can I move tabs from left to right? Why have I not tried that before? Close tabs to the... No, that doesn't work. Close others. Close others. No. No, that would be too easy, guys. Okay. So, this is print line. A lot of boilerplate, but you can understand it. If you really squinch, you can see that we call IO print on some operations. We match on X. We ask if X has a display implementation. Or actually, no, we ask if there is an X, and if so, we format it with display, and then all of this boilerplate is just the print line macro. But the main part is you can do all of this from your IDE. You don't even have to use the console if you don't want to. Where was I? Yeah. Another example. You can definitely not read that, but it's a vector and the sorting on a vector. On the right side, you can see what's going on. It's running into vec on it. So it converts your macro into an FN. Yeah, I think that's cool. Turns out there is no support for IntelliJ right now. Yes, I feel with you. Now, I'm a genius, right? I invented Rust tooling, so no, of course not. There are many other people that did a much better job than me. And just look for a few other crates and try them. First off, there's Cargo Expand, which is really good. It's more focused on macro expansion, though. But more or less, we use the same built-in functionality now. We also use the pretty print crate for printing this stuff. And maybe those projects will merge in the end. Then there's Cargo ASM, which shows you the assembly code. And I have an example open here. I don't need a Luca. Um, why is it that I always move to the other? Yeah, yeah. Uh, so that's the file opening thing again, running on cargo ASM. And this is the assembly code that the compiler will generate for you. Not going to go into that, but that will be a whole different talk. I'm just saying that you can do all of this with very, very simple tooling that is readily available for you. And last but not least, there's also cargo bloat, which will show you what functions take up the most space in your binary and how much storage you could save by removing those functions. All of those, including cargo inspect, are very nice to get to know the compiler. I also advise you to just compile the compiler once. There are instructions in the Rust C book and debug it. Just give it a shot. And if you say, yeah, IDE tools and terminal tools are not really mine, just try the same thing on the playground. You can print the here, you can print the mir, you can print the ASM, all from your browser. And finally, I want to give a shout out to this guy, Gobbold, which is more or less by now a verb for inspecting compiler internals. On this website, you can not only compile Rust code, but also C++ and many, many other languages. And it's just crazy. So to wrap it up, what have we learned? Rust allows for a lot of syntactic sugar, but it's sometimes good to be reminded about that and to know what's going on behind the curtains. And tools can help you understand what's going on. And you should write more such tools and use such tools. And that's why I say, go and build awesome and cool things. And if you are really in the mood to get your feet wet, then there are a few issues that you can take a look at. I don't think many of them will be really hard, and so those are good for starters. The code is super simple. It's more or less a few hundred lines, so really no big deal. And there are a few things that people are missing and so on, and so maybe if you want to contribute, please feel free and talk to me after the talk. That would be great. Finally, some credits, and also look at the Rust compiler guide. I will upload the slides somewhere. In case you're one of the people that keep asking me for another episode of Hello Rust, yes, it's in the pipeline. Yes, I just have to get around to do it. And yeah, with that, thank you for your attention. I guess we have time for 2 questions or so.
How can I get more socks?
The question was, how can I get thrown out of this room? Yeah, there will be socks. Yeah, pick up your pair. Even if you haven't answered any questions, I want you to use that as a reminder that you can do all of this, and always wear those socks when you're programming Rust. There are even gears on it. So, wow. Yes. Yeah. The question was, have I tried expanding the no standard crate? No. It turns out that if you have very, very big code, the compilation, the output, it will be quite substantial. I haven't even, so that's why I used small snippets. But you can definitely do that. I mean, I tried compiling very, very big crates, and sometimes by accident, and then I was like, wow, what is all this code? But yeah, you can look at the STD. It would be a nice thing to do, really. Maybe you can even, yeah, maybe you can do it. Okay, so the question, well, actually, it wasn't really a question; it was a statement. Uh, it was a feature request to implement source code maps that are also common in Java and make it available from VS Code so that people can inspect what's going on, especially when you cross-compile. More or less cross-compiling? Yeah? No, not cross-compiling. Not really. Of course not. But yeah, maybe create an issue and then we can figure it out maybe. Yeah, sure. And also, someone has to make an IntelliJ plugin for it. Otherwise, I will be very sad. Okay, I guess that sums it up. Thank you very much.